If c equals c of x is a total cost function for a commodity, then its derivative, the marginal cost function, is equal to the derivative of the cost function, and that is the marginal cost function. Example 3 says, Mr. Kwan opens up a business where he sells pajoveralls, which are pajama overalls. He finds that the fixed costs of operating his business are $2,000 a month, and it costs him $15 to make each pair of pajoveralls. Find the cost function. Now, this is kind of some review from a previous math class, like Math 111, but the cost function is equal to the fixed costs plus the variable costs. And in this scenario, the fixed costs are $2,000 a month, and then the variable costs are $15 for every unit produced. And so really I should be putting c of x here. So let me put c of x. So this is our cost function. And we want to find the marginal cost. So c prime of x, that's the marginal cost function. And that is equal to, well, if we took the derivative of 2,000, that would give us 0. And then the derivative of 15x is just 15. So notice that this is a constant function. And what can we interpret from that, or what can we gain from that? Well, that's basically saying the marginal cost function is always 15, and that just means that the cost to produce one additional unit is $15, which should make sense because this is a linear function. And the only additional cost is this, our slope, which is $15 here. So our marginal cost function is just 15. Suppose the daily total cost in dollars for a certain factory to produce X kitchen blenders is given by C of X equals 0.001x cubed minus 0.3x squared plus 32x plus 2500. Part A says find the marginal cost function for these blenders. So the marginal cost will equal the derivative of the cost function, which is going to be 0.003x squared minus 0.6x plus 32. And that is our marginal cost function. Part B says find and interpret the marginal cost when x equals 80 and when x equals 200. So we want to do c prime of 80 and c prime of 200. So I'm just going to go ahead and plug those numbers in. So c prime of 80 is equal to $3.2 per unit, or dollars per blender. And c prime of 200 is $32 per blender. So I'm just going to verbally say the interpretations, but c prime of 80, the 3.2 means that we estimate the cost of, or we estimate that making or producing the 81st blender will add to the total cost by $3.2, and then making the 201st blender will add to the total cost by $32. So I'm just going to go ahead and box my answers there and make sure that you write your interpretation down below. Let's talk about marginal profit. If P equals P of X is the profit function for a commodity, then the marginal profit function, MP bar, is equal to the derivative of the profit function. Now, this is some review from a previous class like Math 111, but students will sometimes get confused about the relationships between the three types of functions. So There's P, which is the profit function. There is R, which is the revenue function. And there is C, which is the cost function. And I have a little mnemonic device to help me remember the relationship between these three, but if you have a better way of thinking about it, please use that. But, say you are on social media and you found some really good lighting, and so you take a picture of yourself because you think you look really good, and then you post it on like social media like Facebook or Instagram, and then you get like 100 people saying really positive things about you, like, oh wow, you're so beautiful, you look like a model. But then you have that one a-hole that's like, you look like a cow. And people tend to focus on the negative comments, even when you have a surplus of positive comments. When you're focusing on social media, you tend to focus on the negative comments. And so that was a very long-winded way of helping us with the mnemonic device. The profit function is equal to the revenue function minus the cost function. And so the mnemonic device I use is people read negative comments on social media. So, P is the profit function, R is the revenue function, negative represents the fact that we're subtracting, and then the cost function is the comments. So that's how I remember it. Example 5 says, a firm in a competitive market must sell its products for $200 per unit. The cost per unit per month is 80 plus X, where X represents the number of units sold per month. Find the marginal profit function. So before we can find the marginal profit function, we need to find the profit function. And remember that profit is equal to the revenue function minus the cost function because people read negative comments. So P of X is equal to the revenue function. So if they're selling their product for $200 per unit, then the revenue that they're going to gain is 200 times the number of units that they sell. And then the cost is going to be 80 plus X times the number of units. And so let's simplify that a little bit. So we get 200x minus 80x minus x squared. So I went ahead and I distributed both the negative sign as well as the x. And if we simplify that, we should get the profit function is equal to 120 minus x squared. Excuse me, that should say 120x minus x squared. That looks a lot better. Okay, from here, in order to find the marginal profit function, we want to take the derivative of the profit function, which is going to be 120 minus 2x. Now, one thing that you kind of want to think about is this here is not always going to be a positive number. So there are values that you could plug in for x that are going to make it negative. So if you were to set that derivative equal to 0 and solve, so we'd get 120 equals 2x, and then if I divided both sides by 2, we'd get x equals 60. After 60, the marginal profit function starts to be negative, which means that after you start producing and selling 60 units, the profits are going to start decreasing. So this is the number of units that's going to maximize profits. And again, we will talk more in depth about that in a later section. I'm just going to go ahead and box our final answer. So this is our marginal profit function, which the question was originally asking for. Example 6 says the graph below shows a company's total revenue and total cost functions. If 100 units are being produced and sold, will producing the 101st item increase or decrease the profit for the company? So if we come down here to the x-axis, 100 is right here. So that is where we want to be looking at if we're producing 100 units. Then we want to think about the marginal revenue function as well as the marginal cost function, and those are related to the slopes at these locations, the slopes of the tangent line. So if I drew a little dot right here, the slope there would look something like that of the tangent line, and then for the cost function, the slope of the tangent line or the tangent line itself would look something like that. And which one is steeper? So take a minute, pause the video, ask yourself, which of those lines has the steeper slope? If you said that the revenue function has the steeper slope when x equals 100, you would be correct. So what that means is the marginal revenue function evaluated at 100 is steeper, or that numeric value is going to be greater than the marginal cost function at 100. And so let's see, how can we think about this? I have an inequality here that I could kind of manipulate. So if I subtracted the marginal cost of 100 on both sides, then I'd have a new inequality that said the marginal revenue at 100 minus the marginal cost at 100 is greater than 0. And this thing here is just the marginal profit function. So marginal profit function at 100 is greater than 0. So that means that if you sell the 101st unit, it's going to increase your profits. But something to take into consideration is still the cost here, if I move just a scooch over like 101, notice that the cost is still higher than the revenue. So you're still going to be losing profits, but it'll be a smaller gap if you make that 101st unit. So you still want to make that 101st unit. So finally, our answer, we want to say producing the 101st unit would increase profits.